Let's take a look at example 3 of simplifying trig expressions using Pythagorean identities. This is going to be one that's a little bit more advanced because we have sine to the fourth of x minus 2 sine squared of x plus 1. However, we're going to follow the same steps we were doing in the previous examples, and we're going to get the right answer. So step 1 is to simplify the factors using Pythagorean identities. So right off the bat, when you look at this, you've got a fourth power, a second power, and a first power. And again, you don't always do step 1, but you always look to see if you can. Well, none of these have a fourth power in it. And the sine squared, I'm not going to replace it with 1 minus cosine squared. So I'm not going to... Step 1 isn't applicable in this case. But again, sometimes it is, so you need to follow the protocol. Step 2 is to factor once, not completely. So it turns out I can factor this expression. We did it something like this in the factoring trig expressions lesson. I'm going to replace sine with a. So now I just have a to the fourth minus 2a squared plus 1. That way I can easily see I can use the x method. Okay, two numbers that multiply to give me 1 and add to give me negative 2 are negative 1 and negative 1. So therefore, I can now factor this using these two sides of my x. And again, if you don't recall the x method, you need to go back and watch that lesson on factoring trinomials. And again, we're only factoring once for this step, not completely. So I'm going to use those minus 1s to break down my middle expression minus 2 into minus 1 a squared. Now they both got to be a squared because that middle term is also squared, so make sure they're both a squared. Now I'm going to pull out an a squared from my first two terms. I'm left with a squared minus 1. I'm going to pull out a minus 1 from my second two terms. I'm left with a squared minus 1. Since they both have an a squared minus 1, that's going to become one of my factors. The leftovers, which is a squared minus 1, ends up being the other factor. So this is actually a perfect square trinomial. So now I'm going to replace a with what it was equal to, which is sine. So now I have sine squared of x minus 1 times sine squared of x minus 1. That could be factored again. However, you only want to factor once for step 2. So now I've factored this expression into sine squared minus 1 times sine squared minus 1. And I only used one factoring step, namely the x method. So step 2 is complete. Let's move on to step 3. Step 3 is to repeat steps 1 and 2. So if we're repeating step 1, we can now try to simplify using Pythagorean identities. So let me ask you, does sine squared minus 1 look like one of the identities? Well, yes, it does. It looks like the first one, sine squared plus cosine squared equals 1. So basically what we're going to end up doing is subtracting the 1 over here, so it looks like sine squared minus 1, and moving the cosine squared over here. So we're going to end up with a negative cosine squared on the right and sine squared minus 1 on the left. Therefore, we can now substitute sine squared minus 1 with negative cosine squared. We can do that for both of these since they're both the same. So now we're going to take sine squared minus 1, replace it with negative cosine squared, and do that for both of them. And again, step 3, we're just repeating steps 1 and 2. Now that we've simplified using Pythagorean identities, now can we factor it? Since we're going to repeat step 2. No, this cannot be factored. So we're going to jump to step 4, which is to simplify using quotient identities. So the question now is, can we use quotient identities to simplify this expression? No, because they're both cosine, right? When we do quotient identity simplification, we turn everything into sine and cosine, but it's already that way, so NA is not applicable, but step 5 is. We will now simplify. And notice that they're both negative, so it's going to become a positive, and they're both squared, and they're both cosine, so it's going to become cosine to the fourth. So the final answer for this one is cosine to the fourth. And as always, I like to rewrite the question. The question was to simplify sine to the fourth x minus 2 sine squared of x plus 1. We followed our 5 steps correctly, and we've ended up with something much simpler, which is cosine to the fourth of x. That's it for this example of factoring trig expressions using Pythagorean identities. Don't forget your identities. They're very important. There's only 3 of them, and if you follow these steps, you will get the right answer every time. If you have any other questions about this example, let me know.